Yeah. The reason why we wouldn't include the bottom of this shape is because of the context of the question. They told you that you had a building in Sylvan Lake. And if you were talking about the surface area of a building, you wouldn't be talking about where it's touching the ground, right? It would be like overlapping with the ground. So you wouldn't count that side. You would only be doing the sides you can see, like the outside walls and the roof. That would count as surface area. Tackling this question. There's different ways to do it. I'm going to show you a third way. So the first way was we could do the area of everything minus the area of the overlap, and that would give you the area of the painted. Second way was we could figure out how many faces there are, subtract the overlaps faces, and that would give you the total number of faces, which you then would calculate the area of. Third way, if you're good at visioning these things and you can see them really well, you could just try to count the number of faces that you need to paint. And some people can do that. Some people can't. Right? Some people see the overlaps. Some people see the outside edges perfectly. So I'm going to try that way. I'm going to see if I can count the number of faces I would paint. So if I'm looking at this shape, this first box right here, I would have 1, 2, 3, and then I'd have another guy in there for 4.
So you wouldn't count the bottom, like, because it'd be on the ground?
Right, because the bottom is on the ground, so it's not part of the surface area. If we counted the bottom, that would be 5. But we're not counting the bottom because this is a building on the ground. And since we can't see it, we're not counting it. And it says exclude the bottom faces.
So then what about the back one?
We will do that. We're just not there yet. Yeah.
So like if we're excluding the bottom faces, can we do like the ones on the top level?
Yep, you still do the top and you still do the back side that you can't see. Like the back of the building. So again, it's 1, 2, 3, 4 for this first cube. Then there's a cube behind it. That cube would have 1 and then 2 on the back side. So I'm at 4 plus 2. This guy on the top would have 1, 2, 3, 4, 5. That would be 5 on that top cube. This next cube right here would be 1, 2, and then on the back side would be 3. Right? I would do the front, the top, and the back of it. The next guy would have 1, 2, 3. The next two would have 1 right there, the back side, which is 2, and then another back side over there, which is 3. Then the top one would be 1, 2, 3, 4, 5. So if you're able to consistently look at those shapes and just count out the number of sides, feel free to use that method and then add all those numbers up. If you added all those, you end up getting 11, 20, 25. Anybody run that through their calculator? Did they get 25? So it is possible to just look at a shape and add the outside edges that you can see. If you are good at doing that, then do that. If that is not your strong suit, then do one of the other strategy we used. Right? Multiply all the sides, subtract the sides that you're overlapped, and that would work fine. No matter what, you should get 25 sides times the area of one side. What's the area of one side? They told us it was 6 centimeters.
36.
So 6 times 6 would equal 36. 36 is the area of one side. Total number of sides times the area of one side would give me the total area of the entire shape on the outside. Again, I got that 36 by going length times width, which is 6 times 6. If you throw it in your calculator, what do you get as an answer? 900? A nice round number. So the total area is 900. Awesome. It's up to you how you like to tackle questions. That's now 3 different methods. I will never judge you for the method that you choose, right? Like, you won't get graded on that. As long as you have a method that makes sense and you can do it consistently, you'll do fine. Example 4. This is a one where it might be hard to count the number of sides, right? Because you kind of lose sides in the middle. And you have these partial sides, right? Like, if you look, this is only a partial face because some of it's covered. So that might be a hard one to count the number of faces. It's probably a good one to subtract on the overlap of faces. Yeah, Brad. Yeah. 4. So for me, if I was doing this question, it says each cube has a length of 4. Each length has a cube of 4. So if you wanted to find the area of one face, it'd be 4 times 4 equals 16. It's probably smart just to figure that off right off the start. I should have done that last time. Would have been probably more efficient. So find the area of just one face. The second thing I would try to figure out is the number of faces total. To do that, you need to count how many cubes there are. For us, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 total cubes times 6 faces for each cube gives you 84. I'm not confident in that. So we try it? Thank you. There's 84 faces total. Then I would do the number of overlap faces. Number of overlap faces. That's what OL stands for, overlap. There's 22. 42 overlap faces? Okay, so remember with this one, we did do it before, right? So again, if you get confused with what I'm about to say, if you go back to your lesson 2.6, we did this exact shape and we did the number of overlap. And I think it was 42. I'm going to point where they all are and why it gets kind of confusing. If you look up here, that's 1. And then there's 2 of those, right? Because there's the face here, but then there's like the face on the downside of it where it's touching. So that's 2 right there. Then it'd be 4, 6, 8, 10. Then you would do your down again. So it'd be 12, 14, 16, 18. And then you have all of these sides in here. And there's a lot of them. Right? So depending on how you want to tackle that, I'm already at 18. I would go 20, 22, 24, 26, 28, 30, 32, 34, this one. And then you got that inside cube, right, which is taking away even more. So there's a little 1 cube in the middle of all that, which takes away another 2, 4, 6, 8, gives you 42 total sides that are gone. Again, we broke that cube down into more detail in 2.6. So if you have a hard time seeing that there's 42 overlaps, then go back to 2.6 and try to see how we did it. We took a long time on this one. We did a long time on that one too, yeah. Now that I've got the number of faces total and the number of overlap faces, I can do the number of painted faces. that number will be 84, which is the number of total faces, minus 42, which is the number of overlap faces, to give me a total of 42 faces in total. So we took our 84 all faces, subtracted our 42 overlap faces, left us with 42 faces that need painting. I then can calculate the total surface area of this thing by taking the area of one face and multiplying it by the 42 faces that need painting. And you get 672 as your answer. That's a hard question. It's going to take time to break it down. You all watched me on 2.6 struggle to count the number of unpainted faces, the number of overlap, right? So I expect it to be hard and challenging. And I expect you to make mistakes. The best way to make sure that you don't make a mistake on a quiz is to do it more than once. Right? Count the number of overlap faces, then try it all over again. And count the number of overlap faces again. And see if you get the same number twice. If you do, hopefully you didn't make a mistake twice. Hopefully. If you did, that's life sometimes.
Confused on how you counted the overlaps.
The number of overlaps? It's tricky. There's two different types of overlaps here. We have like tops and bottoms, and then we have sides. Okay, so if I'm looking at the tops and bottoms, and I'll try to go quick because we did go over this in our notes previously. But if you look at the top and bottom, there's two right there, right? The bottom of that top one, and then where it's touching. And then in here, there's 8 more, right? For the tops and bottoms. Because there's the bottoms of those 4, and then you double it because it's taking away the same amount of space. Then you have to do all of the sides of the cubes on each layer. So if you're looking, this middle layer, try to do a different color. This middle layer would have 2 right here, 4 right here, 6 back here, 8 more there. So that would be 8 more overlaps on the sides of all those cubes in the middle. The hard one is trying to envision this bottom layer right here and all the sides that are being taken away. That's definitely the hard one. To figure that out, it might be wise to even redraw just that layer so that you can kind of see it. And that layer would somewhat look like this. Oh, good luck, Mr. Kennedy. Yeah, there's 9 squares there, right? So if you're looking at it,
inside the squares, there's more squares to make more squares.
Right, that's kind of what the bottom layer looks like. Hopefully a better drawing than that, but it somewhat looks like that. And if you were trying to count all the overlaps, there'd be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There's 24 total overlaps in there, just on the sides, which is a lot. And that's a hard one to kind of get. If you were to add all those numbers, you get 42.
Well, it makes a circle.
It does. Just the way I was turning them too. Does that help a little bit, Jake?
Yeah.
It's tricky, man. Like those ones are hard. And if you try to sketch them, maybe it'll help a little bit. Your sketch doesn't got to be pretty. It's just got to make sense to you. Right? Like that's not a good sketch in the bottom right-hand corner. But hey, it works. Okay. That's doing composite shapes that were all cubes. I think, honestly, those are the hard ones. I truly do think that. These shapes like this aren't nearly as bad, in my opinion. So we've got this shape. It's a composite shape because it's 2 shapes connected. we want to calculate the area of the following. So that's the surface area, all the outsides. We would include the bottom because it didn't tell us not to. We're assuming this is like a shape I can pick up, dunk it, and paint to pull it up. To figure this question out, I think it would be wise to do total area and then subtract away overlap. That's how I would do it, probably. Another way to do it would be to try and just figure out the outsides and add them all up. Kind of each their own. I'm going to start with total area, and I'm going to start with this shape right here. Yep. These were on your notes yesterday, but we did the overlap area only yesterday. Today we're doing the area of the outside edges.
Is it the full square? You just color in the full square?
Yeah, so I'm doing the whole surface area of everything I can see. So the area of the blue guy, the area of the little one, which I've colored in blue. This front side would be length times width, which is 3 times 6. Then I would do this side. The area of that side is 3 times 6, and I'm going to times it by 2 this time. The reason I'm going to times it by 2 is because there's a second one over here, right? I can't see it, but I know it's the exact same as that one I can see, and I am going to have to paint it because there's nothing against it. So I went 3 times 6 times 2, and what'd you get? Hopefully you got 36. That's length times height, or length times width, times 2, because there's 2 of them. It's 36.
So if you want to connect the equation, you could do 18 times 6.
Yep. Because they were the same, right? They're the same width.
Technically, it's 3 times 2, which is 6, and 6 times 6 is 36.
That would work too.
Yeah. 36. There's that one.
It's the area of that right side and the area of that back side. Yeah, guys. Yeah. Gentlemen, we're still moving on. You then would have, yeah, Brennan.
Can you do 3 times 6 times 4 since there's 4 of those little shapes on it?
Depending, I'm just doing the area of what I can see on the little one.
Oh, okay.
That's why I didn't times the first one by 2, because the second side, this one right here, is against it. So I wouldn't paint it. So I just didn't times by 2. I'm only doing the area of what I can see because I think that's easier for me. Does that make sense? Yeah. And if you want to do it that way, that's fine. And then subtract the overlap later and you'll be good. Yeah, Joe.
For the next one, can't you just replace the 3 for 12 and add?
I'm not on the next one yet. Just wait.
Couldn't you just times that by 3?
Yep, so you go 3 times 6 times 3 because they're all the same. That would definitely work, right? Like with these questions, there's going to be more than one way to approach it. So if you wanted to do 3 times 6 times 3 because you realize that all 3 rectangles are the same on the outside edge, that's fine. Yeah, that would work absolutely. I did it as the front, but the sides aren't all always going to be the same. So that's why I then broke down the sides differently. Awesome. Now I'm going to do the top. The area of the top would be 6 times 6. And then I'm going to times by 2 because of the bottom. Right? The bottom we are going to include because we're going to pretend this is a shape I can pick up and put down. Yeah, Joe. Yep. That means the total area of the little guy that I'm painting would be 18 plus 36 plus 72. If you put that in your calculator, you should get 126.
Yep.
90, yeah, 126. That's the area of the little shape. Yeah, Jake.
Well, it says like 6 times 6 times 2. I just did 12 times 6.
That works.
That's also not an math teacher as a dad.
Would help.
Yeah, it would.
Of little, yeah. of lit.
It would be
You
good
teach
for
Hey,
math.
now we're going to try to do the area of the big guy.
Oh, the big boy. Talk about you.
To do the area of the big one, I'm going to do the sides first. This one right here. That's going to be 6 times 6 times 2 because there's another one on the back side for a total of 72. Six times 6 gives me the one face. I times by 2 because we got this side over here that we can't see. Then I'm going to do the top and the bottom. The top right here would be 12 times 6 times 2. Because the top and then there's the bottom side we can't see. That would be 144. Then I'm going to do the back, which I can't see. The back would be 12 times 6. And then if you wanted, you could times by 2 and then subtract. But what I'm just going to do the back as if it's one side by itself. And I'm going to leave this front where there's like a missing gap. I'm going to leave that alone for a minute. And I'm going to do that one by itself. But if you can see how you would double it and then subtract, do that. Me personally, I'm just going to show you the backside separately. So 12 times 6 would be 72. That's the backside. The last one I'm going to do. I'm going to do it in a different color so it kind of stands out. I'm going to try to figure out the area of this thing. This awkward shape up front. If I wanted to figure out the area of that shape, what I would need to do is do the entire area of that rectangle, because the rectangle looks like this, which is 12 times 6. But then there's this overlap region. And I need to subtract that away. Yeah, Dave.
So if you find out the area of that rectangle, which would be 72 because it's 12 times 6.
Right?
And then we already know that the little side on the smaller prism is 30 or 18 rather. That's one side. So you do 72 minus 18 and then you get your answer.
You got it. So I'm doing 72 because that's the area of that total side, the big rectangle. And then I'm subtracting 18 because that's the area of the rectangle that's against it. That's what's missing. And we had calculated both those areas before, right? Once earlier from the big triangle, once from the little guy earlier. I said triangle, I meant rectangle. If you go 72 minus 18, what's that side? 54?
Yep.
If you add all those together, you should get 342. Thank you. That's the area of the big. If you wanted to figure out the surface area of this whole building, you add them together. My final answer is 126 plus 342 for a total of 468. I think that's the best way to approach that question. There are other strategies. Sometimes people see things in different ways. If you see that in a different way, do it. If you get the right answer, awesome. As long as you have a consistent method that works for you, I'm happy. That's my method. Yeah, Brandon. Yes, sir. Brad.
Is in like higher levels of school, is there methods that you have to do? Or is this method kind of always work?
So we got this guy right here. We have a triangular prism with a box on top of it. If I was doing this question, I would calculate the area of the box that I can see And then I calculate the area of the triangle that I can see. And I do that as one whole thing. So I'm going to start with the box. On a box, we just do length times width times the number of faces you can see. The length and the width are 3. So I'm going to go 3 times 3. And the number of faces I can see is 1, 2, 3, 4, 5. So times 5. For a total of 45. That's the area of the whole box. Easy peasy. 3 times 3, because that's one side, times 5, because there's 5 sides that I can see. The 6th side is on my triangle, so I can't see it. The prism is going to be a little bit trickier. I might give myself a little more space here. Prism. When doing the prism, I'm going to do the sides first because those are typically easier because they're rectangles. So if I'm looking at this front side right here, that front side is 15 times 6 for a total of 90. I cannot multiply by 3 because the rectangles aren't all the same size. Each rectangle is a different side because they all have a different length. They all have the same height of 6, but they all have different lengths. So I can't just times by 3. I'm going to have to do each side individually. A little slow. If I want to do the left side back here, that would be 12 times 6. 12 because that's the length. 6 because that's the height of it. If you put that in your calculator, you should get 72, which we've seen a lot of today. Yeah. The third side back here, the third rectangular side would be 9 times a height of 6 for a total of 54. Awesome. Those are the rectangles around the outside of that prism. I'm now going to do the bottom. I'm leaving the top for last because the box and the top are touching, and so I know it's going to be kind of a pain. So I'm just going to do the bottom first. The bottom would make a triangle, which would look the exact same as the top. My formula for a triangle is base times height divided by 2. So for that triangle, the base would be 9. The height would be 12 divided by 2. And you should get 54. And that's for the triangle.
So when you do 54, you do 45.
Close. Here, let me check. It's 54, right? Somebody threw it in their calculator?
Yeah.
For some reason, I'm doubting myself. Hey, that's the triangle that's on the floor. If you want to do the triangle that's up in the air, I'm going to erase everything just so I can really focus in on that because that's definitely the hardest part. This triangle in the air. I'm going to do it in orange. I need to do the full triangle and then subtract where the box is touching. So if you were to look at this as a picture of just the triangle, it looks like this. With a box right in the middle. I do triangle minus that box. We already know what the area of the triangle is. The area of the triangle is 54. Right? It's the same as the area on the bottom. It's the exact same triangle. Just one's on the top, one's on the bottom. Then we're going to subtract away the box. What was the area of one side of the box, Brandon?
9.
It was 9. 3 times 3. So if you put 3 times 3, that's fine. If you just put 9, that's also fine. And that'll give you the area of the top, which is 45. Again, like we did before, you're going to add all those numbers up. That one I'm not going to do successfully in my head, so I'm going to ask for someone to calculate it. Darian's on it for me. So you'd go 90 plus 72 plus 54 plus 54 plus 45 to get the total area of that triangular prism, 315. You then could add your totals together to get the total surface area of this object. 45 plus 315 gives me 360 as my total area of that composite shape. Absolutely. How are we feeling about that? Gucci. Wonderful. This guy. We're going to tackle it the same way, where you're going to try to do the area of all the sides, and then I think it's best to do that last side that overlaps and subtract away the circle that's touching it. That's my best approach to it. I want you to give it a shot on your own. So see if you can find the area of all the sides, then subtract the circle. I will put the area of a circle formula up so that you can kind of copy it if you need to. Say, give it your best shot.